we're going to try to relearn and sharpen our skills on the mole. So what I'm writing on my worksheet, you need to write the exact same thing on your worksheet and follow along so that you can do better moving forward. Because the mole is going to come back big in semester 2. We're also going to see it again on the midterm. So you want to make sure that you are good at these skills moving forward, because this is going to be foundational. How many things are in a mole? Number 1. Well, we know that a mole is Avogadro's number. There are 6.022 times 10 to the 23rd. There are that many things in a mole. All right, the next question is, what can be said about the number of atoms in a mole of iron? So a mole of iron compared to, there we go, a mole of cadmium. And we're thinking about the number of atoms when we compare those two things. Well, we know that in a mole of iron, if it's 1 mole, we've got 6.022 times 10 to the 23rd things. And then I know if I have a mole of cadmium, I've got, as long as it's just 1 mole, I have the same number, 6.022 times 10 to the 23rd atoms. Okay, and so they're the same. I have the same number of atoms. If I've got a mole of anything, I have the same number of things, because 1 mole is 6.022 times 10 to the 23rd things. So it doesn't matter the mass, it doesn't matter the volume, it doesn't matter any of that. We're just asking about the number of things, the number of atoms, the number of particles. And they're going to be the same because we're talking about a mole, 1 mole. All right, for numbers 3 through 7, use this compound. All right, so this compound is Fe2, there's parentheses, CO3, parentheses 3. Notice that the O is capital. It's a capital O. That's important. Okay, and we have parentheses, so let's review what parentheses means. So this means that the 3 here is going to go to the O and the C. Okay, it's not going to go to the Fe because the Fe is not inside the parentheses. So it's just going to go to the O and the C. So that means that I have a total of 3 carbons. And I have 3 times 3 is 9. So I'm going to have 9 oxygens. When I add up my molar mass, which is what the next question asks us to do, I need to pay attention that I need to add up 3 carbons and 9 oxygens total. And don't forget that I also have 2 irons. So the molar mass of this compound. So we need to look up the masses of iron, carbon, and oxygen. So iron, we're going to round this to 2 decimals. So 55.85, and I have 2 of them, remember? Okay, carbon, the atomic number is 6, but I'm looking at the mass. The average atomic mass is 12.01. So 12.01. Remember, we had 3 of those because of the number outside the parentheses. Oxygen, 15.999. We're going to round that to 16. And I had 9 oxygens. $111.70. 36.03. And 144. All right. And to get the molar mass, you're going to add these all together. So you're going to sum. You're going to take the sum of these. And you should get 291.73. And then the units. This is the molar mass, the mass of 1 mole. So this is grams per mole is our unit. Grams per mole. This is the mass of 1 mole, grams per mole. And the next question wants us to do the percent composition of each element in the compound. And so for iron, when we're doing the percent composition, we're doing the percent composition by mass. And I also have to take into consideration how much iron is in the compound. So I can't just do 55.85. I need to do 111.7. So if I just did 55.85, I wouldn't be doing the percent composition of all of the iron in the compound because I have 2 irons. So I need to take this number. Okay, so it's going to be this divided by the total that we did in number 3. So we're going to do 111.70 over 291.73, and we're going to multiply that by 100 to make it a percent. 38.3% iron. That's how much iron by mass is in the compound. Carbon, once again, we're going to take not 12.01, but we're going to take 36.03, the total mass of carbon in the compound, and we're going to divide that by the total mass of the compound. So 36.03 divided by 291.73 times 100. So 12.4% is how much carbon there is in the compound. And the last one is oxygen. Once again, be careful. You don't want to just do 16. You're going to want to do 144. The mass of the total oxygen in the compound divided by the total mass of the compound. So we're going to do 144 divided by 291.73 times 100, 49.4% oxygen. Number 5, it says convert 35.5 grams of the compound above to moles and particles. All right, when we just convert to moles, it's going to be one step. I have the mole map over here. And so if we're starting with grams, we're starting here. And the first one wants to go to moles. So we're going to go this way, which means we're going to need 1 mole over the molar mass. So if I'm going up, I'm going to follow the arrow. So this is the conversion factor I'm going to use, 1 mole over the molar mass. So we're going to start with the number in the problem. The number in the problem is 35.5 grams. I want to use 1 mole over the molar mass. So on this side, I'm going to go 1 mole over the molar mass. The molar mass was 291.73. So that's going to go on the bottom. The molar mass is grams per mole, so that's what I have. I have grams per 1 mole. So your grams are going to cancel, and you're going to end up with moles. And what do you get? How do you plug that in? You're going to type in 35.5 divided by 291.73.122 moles. So for this next one here, we're going to start with, we want to go to particles. We're still going to start with 35.5 grams. And so we're going to go from grams, we're going to need to go to moles. So we're going to use that same conversion factor for our first step. But we don't want to end up with moles, we want to end up with particles. So I'm going to need to use Avogadro's number over 1 mole. So I'm going to use this one first and then this conversion factor. Set it up. We always start with the number in the problem, so we're still going to start with 35.45. Sorry, 0.5, not 45. 35.5 grams. It's important to line up your units when you're doing this. If you set it up with your units and you can see that they cancel because you have one on the top and one on the bottom, then you know that you're probably in pretty good shape. So we said that our first one, we needed 1 mole over the molar mass. That's going to take us from grams to moles. 1 mole over the molar mass. So 1 mole over 291.73 grams. And then for the last step here, to go from moles to particles, I'm going to use Avogadro's number over 1 mole. So we're going to use 6.022 times 10 to the 23rd particles over 1 mole. And let's see how those units cancel. Grams, I didn't cancel them up there either, sorry. Grams cancels, moles also cancels, and I'm left with particles. So when you plug this in your calculator, you're going to make sure that you do 35.5 times, you can do Avogadro's number, and then divided by the molar mass. Or you can do this number divided by this number times this number. I got 7.33 times 10 to the 22nd particles. So on this next one, we want to convert 2.45 times 10 to the 24 particles, and we're going to convert them to moles, and then we're going to convert to grams. So if I look over here on my mole map, we're starting with particles. So we're going to start here with particles, and then we're going to go to moles for our first one. And so we're going to use this conversion factor, 1 mole over Avogadro's number. And then for the next one, we're going to go to grams. So we're going to start with particles, because that's what we're given in number 6. And then we're going to go to moles. So we're going to use this one twice. We're going to use it for A in the 1 step, and then we're going to use it as our first step and B for our 2-step problem. And then once we get to moles, we're going to go to grams. So we're going to go down here. So I'm going to use this one, the arrow going this way. Molar mass over 1 mole. So our molar mass that we found in number 3, 291.73 grams over 1 mole. This will be our second one. So our first one is going to be 1 mole over Avogadro's number. So let's go ahead and set that up. When you type that in, make sure that you are, you're either using your E key like we talked about. So you would type in, this is how you would type it in on your calculator. 6.022. If you have a graphing calculator, you're going to type in second, comma. It's the little button above the 7. So it would look like E, and then you type in the number 23. You don't need to type in multiply. You don't need to type in a caret. You don't need to type in the 10. This is what it means to your calculator. Your calculator, when you type that in, is 6.022 times 10 to the 23rd power. That's what that means. If you're not using the E key, that's totally fine. You don't have to use the E key. But what you need to do is make sure that you're using parentheses. And so you want to put parentheses around that. So if you type in divided by 6.022 times 10 to the 23rd with parentheses, to make sure that your calculator knows your order of operations. I'm going to round it to 2 decimals. 4.07 moles. Okay. B, we're going to start out similar. We're going to do that first step the same way. But then to go to grams, the step that we're going to add is molar mass over 1 mole. And we got that from our mole map over there. There we go. Okay. And then 1 mole on the top. So the molar mass was 291.73. That's grams over 1 mole. Molar mass is in grams per mole. There you go. So again, be careful when you type this into your calculator. If you're not using that E key, make sure you put it in parentheses. When you type this in your calculator, you should not get a number in scientific notation. You should not get a times 10 to the 46 power at the end, or the 47 power at the end. If you did, you need to go back and make sure you're using parentheses the correct way. Kind of a big number. 1,186.9 grams. And lastly, we're converting from moles to A, we're converting to grams, and then B, we're converting to particles. And we have 0.67 moles of the compound. And yes, I did that on purpose, just for you. Just for you. So 0.67 moles. So we are going to go to grams first. So we're starting here in the middle of our mole map. And we want to go to grams. So this is the arrow that we're going to use. So we're going to use molar mass over 1 mole. And it's only a one-step conversion. Anytime that we have moles either given to us or calculating moles, it's one step because moles is in the middle. So if we're going from moles to grams, we're going to use this conversion factor. So let's go ahead and set that up. So you're going to multiply 0.67 times the molar mass, 291.73. $195.5 grams. Let's convert that to particles. So go back to our mole map. We're starting with 0.67 moles, so moles in the middle, and we're going to particles. So we're going to use Avogadro over 1 mole. So we always start with the number in the problem, 0.67. And I haven't been canceling my units, but let's just take a look here. Moles cancels. If we go back up to A, moles cancels. You have to have one on the top and one on the bottom for the unit to cancel. If I look up at B, my two-step problem, particles cancels there, moles cancels there, and I'm left with grams. Okay, if I look at 6A, particles cancels, and you end up with moles. Okay, so what you want to do is, when you're solving these problems, this number here is your number in the problem. This should always be your number in the problem. There should never be anything here. This should always be blank. And then your conversion factor. And you want this unit to be here. Automatic. Whatever this unit is, you want this unit to be the same so that it can cancel. And then if you're on your very last step of your problem, the unit here should be what they're asking for. The unit in the top right should be your final unit that you want your answer to be in. So in this one, we canceled moles, and we're going to end up with particles. 4.03 times 10 to the 23rd. If you have a graphing calculator, it probably tells you E23 at the end, so don't forget that last part. That is important. And then units is particles. Dinitrogen monoxide, or N2O. We're going to use this equation for this page. The first question is, what is the molar mass of this compound? Okay, well, we need to go look up nitrogen and oxygen and then add them together. And we need to make sure that we have 2 nitrogens. So we have nitrogen. We're going to have 2 of the molar mass of nitrogen. And then we're going to add that to oxygen. Oxygen does not have a subscript, so we just have 1 oxygen atom. Oxygen, I'm already on oxygen. Remember that oxygen is 16. We had that one on our previous formula. 16.00, we just round them to 2 decimals. And then nitrogen is, if we round that to 2 decimals, is 14.01. So 2 times 14.01 is 28.02. You get 44.02. And then the units for molar mass are grams per mole. So 44.02 grams per mole for N2O. Okay, and then the next question is, what is the percent composition of each element in the compound? When we're talking about percent composition, we're talking about the percent by mass. So nitrogen, remember that there were 2 nitrogens. So it's going to be 63.7%. That's how much nitrogen is in the compound by mass. And then oxygen, and that is going to be 36.3% oxygen. All right, so it says convert 25.5 grams of N2O. We're going to convert that to moles, and then we're going to convert that to liters. Now, one thing I forgot to write on here is that this is going to be, all of this is at STP. That's going to allow us to use that 22.4 liters for molar volume. 1 mole of gas is equal to 22.4 liters at standard temperature and pressure. There's nothing that you need to do mathematically with standard temperature and pressure, that STP. It just is the conditions that allow us to use 22.4 liters. And remember, this only works for a gas. It has to be a gas in order for us to use the 22.4 liters. 25.5 grams, 2 moles. So grams to moles. We just did that one on the previous page, so it shouldn't be too bad. So we're going to go from grams to moles. We're going to use 1 mole over the molar mass. Set it up. Always start with the number in the problem. Grams are going to cancel. You'll end up with moles. So say 0.58. Just remember your rounding rules. If you're rounding, you should look to the next number to see if you need to round up or if it stays the same. What about liters? If we go from grams to liters, that's going to be a 2-step problem. So let's go back over here to our mole map. So we're going to go from grams to moles. So we need to use this one, 1 mole over the molar mass, just like we did here on the left. And then we're going to go to volume of gas, liters. So we're going to use 22.4 over 1 mole. So we're going to go this way, then this way. So make sure that we're using the right conversion factors. And our units should be canceling if we're using the right conversion factors. So set it up. Our number in the problem is 25.5. So we're going to start there. Make sure you're putting your units so that we can check that they're canceling properly. Molar mass on the bottom, 1 mole on the top. And then to go from moles to volume of gas, we're going to do 22.4 liters over 1 mole. And so making sure that our units are canceling, grams, grams, moles, moles. And just a reminder again, for a unit to cancel, it needs to be on the top and the bottom. And then liters is what we're ending with, and that's what we want, so that's good. So 12.98. Liters. You should always have a unit. We should not have any naked numbers. Okay, we're going to convert 5.45 times 10 to the 23rd particles. We're going to convert that to moles, and then we're also going to convert that to liters. So we always start with the number in the problem. Notice that the particles cancel. Go ahead and try typing that in. Remember, if you're not using that E key, you need to use parentheses, 0.905 moles. Okay, then we're going to add a second step to that. We're going to go to liters. So always start with the number in the problem, 5.45 times 10 to the 23rd particles. Leave yourself enough room to work. You know it's a 2-step problem. Okay, looking at the mole map, our first step to go from particles to moles is 1 mole over Avogadro. And then to go from moles to volume at the top, so to go from the middle to the top, we're going to need 22.4 liters over 1 mole. Okay, showing how the units cancel. Particles is gone and moles is gone, and we end up with liters. So go ahead and type that in, and you should get 20.3 liters. Okay, so for our next one, we need to convert 8.4 liters, and we're going to go to moles, grams, and particles. So let's see up here on our mole map, we're going to start with liters. And the first one is 1 step, we're going to go to moles. So we're going to use this conversion factor, 1 mole over 22.4 liters. And then for the next one, we're going to go liters to grams. So we're going to use that same first step to go to moles. And then we're going to go to grams. We're going to use this one here, going the right direction, molar mass over 1 mole. And then for the last one, C, we're going to go from liters to particles. So we're going to start up here. we're going to go to mole, so we're going to use 1 mole over 22.4 liters. And then we're going to go to particles, so we're going to use Avogadro's number over 1 mole. So let's go ahead and set these up. So our first one is one step. We're going to go moles or liters to moles. So we're going to start with the number in the problem. So 8.4 liters. And like we said, we're going to, over here, we're going to go from liters to moles. So we're going to set it up where we have 1 mole over 22.4 liters. .375. Okay, so this is our final unit. Liters is going to cancel, moles is going to cancel, and we're going to end up with grams. Follow the units every single time. 16.5 grams. And the next one, we're going to set up similar, but our last step is going to be different. Our units are canceling as well, so we're going to end up with particles. So when we type this in, we're going to type in this times this divided by this. 2.26 times 10 to the 23rd particles. So if your exponent is not 23, you did something wrong. You need to go back and look at how you typed it in. All right, and then our last one, convert 0.67 moles to grams, particles, and liters. So starting here in the middle at moles, our first one, we're going to go to grams. So we're going to need the molar mass over 1 mole. Always start with the number in the problem, though. So 0.67. You're going to get 29.5 grams. And then for particles, we're going to go from moles to particles. So we're going to use Avogadro over 1 mole. Again, make sure that you've got 4.03 times 10 to the 23rd, and then put your units, particles. We see how our units cancel. We got rid of moles. We ended with particles. So there you go. If you're thinking that that number looks familiar, you might not be, but if we scroll back up to our first page, 4.03 times 10 to the 23rd, we did the same conversion here on this first page, 0.67 moles. And we converted to particles. So even though we had a different substance, because we were looking at the particles and we started with the same number of moles, it doesn't matter what the substance is because the number of things in a mole is the same. So that goes back up to what we did here on number 2. The number of atoms in a mole of iron compared to a mole of cadmium, you'd have the same number of atoms. You'd have the same number of particles. It doesn't matter what the substance is. And then lastly, we're going to convert 0.67 moles to liters. So moles up to liters, we're going to use 22.4 over 1 mole. Notice that all of these have mole on the bottom because we're starting with moles. We're trying to get rid of the unit mole and convert to whatever they're asking us to convert to. So starting with the number in the problem, 0.67 moles. You're going to get about 15 liters. So if you have questions, please ask your teacher. But you want to go ahead and turn this into your teacher now